like I said, this subject is going to introduce you to virtualization in the first couple of lessons. And hopefully we started that by introducing you to how we can create a virtual machine, defining the virtual hardware in the last lesson, installing the operating system. And I'm just going to put it out there. I think after you get over the fact that this is not an actual physical piece of hardware, and you actually are defining it inside of that VMware workstation, you're almost treating it like a computer, aren't you? How do you install it? In a real computer, you put the media in, you boot up with it, and you start the installation process. In a virtual machine, it's not a physical piece of media. It could be, but it's not. We use an ISO file. We mounted the ISO file as a virtual optical disk, and we still booted it up and it started off the installation. So that's why virtual machines are pretty good, because after you've actually get them up and going, you treat them like any other physical machine. Even with having the window of the virtual machine, it's almost like if you're working on the network and you're remote desktoping to another computer, isn't it? Okay, so if you think of it like that, every time you switch windows, you are actually switching to a remote desktop of a different computer. It's less, you are confused less. I can tell you now, everyone, including myself, when they first get into virtualization, it's a little bit confusing. How do I know what I'm doing where? You know what I mean? The instructions might say run a command prompt and ping this. Well, yeah, like it might say, if you look at the context, you're working inside a virtual machine and it says in the virtual machine do this. But then you might just go, oh, well, it says press start, type CMD, and I've got a command prompt. But is this command prompt inside the virtual machine? No. All right, so when it says run a command prompt inside your virtual machine, you actually have to physically or consciously remember that you need to give focus. Remember that idea of focus? If I'm over here and I want to do something, it's not going to do it inside the virtual machine, because look at where my mouse is. It's outside the virtual machine, isn't it? So if I want to do something inside this virtual machine or inside this window, I need to click into it. And that gives that virtual machine the focus. Okay, so now if I click into it, I can actually perform actions inside that virtual machine. Okay, so I'm logging in, for example, and like I said, it looks and feels just like pretty much every other virtual machine, any other computer you might be working on. And like I said, when you're working on it, you're wanting to do something on your real machine now, move your cursor out and point on it. So now I'm out. You see where my mouse is? It's outside. I press the Windows key. It's going to do it. It's going to do it on my physical machine, not my virtual machine. And if I actually launch a command prompt, I've launched it on my physical machine. Okay. If I move the mouse in here and click in, giving it focus, I press the Windows key. It's going to happen inside the virtual machine, not on the real machine. If I launch a command prompt, it's going to be launching inside. Sometimes the windows look confusing. Like I've got one here and I've got one there. Which one am I actually on? You know, sorry? Yeah, the top one. Or even if I'm, sometimes it looks like this, right? Sometimes it looks like this. Ooh. Is that in the real machine or is that in the virtual machine? So I get tricked as well all the time. So sometimes you just have to know or find out for yourself, okay? So let's get into today's topic. So virtualization, we mentioned how useful it is, and for us in the classroom it's very, very useful, because we wouldn't be able to teach half the things we're able to teach you without this virtual machine. Like I said, at times we're going to virtualize 6 virtual machines at the same time if you're studying towards the networking. But if we had to do that without virtualization, it's like every one of you guys, every one of you students would need 6 physical machines. And we would have to install the specific operating system on those physical machines. And hopefully you don't stuff it up, because if you do, we'll have to reinstall it and reconfigure it to that state. Whereas with virtual machine, we just give you a set of virtual machines, or you create the set of virtual machines, you configure it, you take a snapshot. If you remember what snapshots were last week, last lesson, you actually take a snapshot, and that's a point in time capture of that state of that machine. All right, and therefore, if you go forth and do all sorts of things and you mess it up, you just tell it to go back to that snapshot. It's as if nothing happened. So in a snapshot, it captures the operating system, the programs inside the virtual machine, the settings, and the files. But it also captures the virtual hardware. So let's say I've got this virtual machine. Let's check if I've got a snapshot or not. So I can go to VM, snapshots, and I can see I've got a few snapshot, and I can see I am here. If you notice, that's the snapshot that I was coming off of. So that's relative to that, I am here. So I can see that that's where I am relative to the snapshots. If I actually go and change hardware, if you remember in our last lesson, the worksheet asked you to add more hardware. We can just open up the settings of the virtual machine. If you notice, if you remember, we actually defined the virtual hardware when we were creating the virtual machine. But what if we realize, oh, we need another hard drive, we need another network adapter? Some things can be done while the virtual machine is running. Something has to be done when the virtual machine is off. Just like a real computer. Sometimes you can do like change the IP address of your real computer while it's running, no problems. Plug in your network cable or unplug it, no problems. But if I want to add a new CPU, I can't do that while the virtual machine, while the computer or virtual machine is running. So let's adjust this a little bit. With the RAM, you'll see that when I actually click OK, it actually restarts the virtual machine or in the background. I can add another hard drive. Create a new one. I'm going to add this as 100 gigs. And if you remember, we told you to store as a single file. And we told you to not allocate this, not tick this one, which is allocate this space straight away. Do you guys understand why? Maybe it's a good time to explain it. So first of all, if I actually choose to split into multiple files, it means it's, instead of having one big file for the virtual hard disk, that's the thing that grows really big because that's what your data's on. If you, for example, have 100 gigs of data stored on your virtual machine, that virtual hard disk will contain that 100 gigs of data. So you're going to have a 100 gig virtual hard disk file. But if I choose this option, it's actually going to split the virtual hard disk file to smaller bits. Can anyone think of why they might want to do that? Maybe. Maybe. Anyone else? I'm not clear with what you're saying, but it could be something leading something. Let's put it this way. What's the maximum file size you can put on a FAT32? 4 gigs, right? So if we had a 100 gig file, could we put it on that? No. So basically, when we actually split the files, we are making a small 4 gig files, which means of a 100 gig file, it will end up with 25 4 gig files, which allows you to put on that FAT32. But for us, hopefully you're all using NTFS on your portable hard drives, so that the size of the hard drive, size of the files can be the same size as the hard drive itself or the partition itself. The other thing is I tell you not to do this because if you read it, allocating full capacity enhances the performance. That's a bonus, but it means that space is going to be used up straight away. Well, if we add this hard drive, nothing's going to be on it, is it? So why are we using up 100 gigs straight away? So by ticking it, we are going to use up that 100 gigs straight away, whether we need it or not. By unticking it, we are actually going to let the disk grow as we fill up with data. So that's better because we are using this as a test machine rather than a real production machine. And we also don't have too much disk space, especially if you've got a limited size SSD. SCSI is because that is the default here. All right, so this is the and reason why you use SCSI is because that's what's recommended. But this just emulates or simulates the virtual hardware as if it was SCSI. Okay, if we chose SATA, as far as the operating system is concerned, it's going to see that that hardware as virtual hard disk as a SATA hard disk. Okay, but because it's recommended SCSI for us, that's why we've recommended that. You might, one second, you might notice there's the IDE, which is an older type, and the NVMe, which is the newest type, also there, but it's grayed out. It's grayed out because of the fact that my real physical machine can't actually support those two. You get me? Okay, so these are the two that it does, and in that case, SCSI is recommended. Okay, does that make sense? Someone else want to ask a question just then?
Yeah, what's the
Oh, SCSI, it's just a different. If it was a physical computer, it's a different cable, different types of cable, and basically SCSI is more for server grade machines, and this is more for desktop type machines. Other differences include that SCSI traditionally offloads some of the transactions from the CPU and system to the SCSI board itself, which means it's actually, if it was a physical hardware, the SCSI card actually does some of the work for your computer rather than you relying on your your CPU and system board. You get me? Okay, it's just like me needing to build a wall, but me getting a contractor to do the foundations for me. I don't have to do the whole thing. I just get someone else to do the foundation. I can just worry about the wall afterwards, okay? So that's what SCSI does over SATA traditionally. And the newest form of SCSI, if you're looking at hardware, is what's called SAS, which is serially attached SCSI. All right, so let's get back to here. We're going to create a new 100 disks, and we get to name it. And we're going to call it the window, we're going to call it the something that makes sense, hopefully. 100 GB. And I'll click Finish, and I'll click OK. And you'll notice that it's gonna restart it, and then it's gonna have those hardware available. So one of the easiest ways to see the hard drive is to open up Disk Manager, and hopefully there's that new disk that's popped up. We need to initialize it, and now it's a blank unallocated space, and we can create a new simple volume. All right, we're not going to worry too much about what's called and whatnot. But you may have noticed that it popped up with some USB connection prompt just then. Basically, when you plug a hard removable media or something that's USB, the question is, do you want to use it on your physical machine, or do you want to use it in your virtual machine? So right now I've got this little USB stick, just like it's probably only got less than 1 gig, so it's very small. It's an old one, but it's just like any other USB stick. When I plug into my physical computer, it's going to prompt me: do I want to connect it to host my physical computer, or do I want to connect it to the virtual machine, Windows 10? If I say Windows 10, it means that Windows 10 owns that piece of hardware, and it will pop up and use it on Windows 10, the virtual machine that is. And now if I actually open it up, I can see that there's my removable hard drive. So it's that USB stick. So, but that means if my virtual machine is using it, my real machine can't use it. So only one device, one virtual machine, one operating system can actually access it at any one time. So if I want to actually get rid of it, I can go to the virtual machine, go to removable devices, and there's that storage device. I'm going to disconnect it from this virtual machine, which will then connect it to the physical machine. And now that I've disconnected it, you see it's disappeared. Okay, that's that 100 gig one that I created before, but the removable one's disappeared. And if I go to my physical machine or host machine, there it is. Okay, so just remember that you can, with USB devices, connect it to the host or the virtual machine, and you can use it. You might see that there was this Plantronic C310M. That's actually this headset I'm on right now. Okay, it's disconnected, and if I connect, I'll disconnect that from my real computer and connect to my virtual machine. So we've reviewed some of the things we were looking at last lesson. Let's get on with what we're supposed to be talking about this lesson. So today we're going to look at some of the virtual machine VMware features that becomes useful, and we're going to demonstrate some of these, and in your worksheet you're going to work through some of these. All right, so let's get into it. Today's objective is to actually look at some of the display options. How do we move or copy virtual machines and what's the difference? How to clone virtual machines, how to encrypt virtual machines, and how to configure adding devices to virtual machines, which sort of I demonstrated there. Let's look at the display options first of all. All right, so rather than talk about it just from text, let's just show you and talk about it at the same time. So we should know that this view is pretty common. Okay, so we've started with this view. You notice that it's got a library on the left pane. So this, if you have multiple virtual machines open, this is where you would have other virtual machines displayed, where virtual machines you've got available to you. And you'll see here, if I've got multiple virtual machines open, you'll see that there will appear as tabs. It's a bit like your browser. So I can switch from one to the other from the tab, and you can see there's a home here as well. Here's the library. If I don't want to see that library, I can just click this button and get rid of the library. I can obviously bring back the library by pressing that button again. And here, this shows a thumbnail of all the virtual machines I've got. So in this case, I've got my Windows 10 and only that one right here. But if I had others, I would see the other virtual machines. That's not as useful to me. I usually turn it off. We also have this full screen mode. So just give me a bit of error message about the screen layout, the screen size. When you're in this full screen mode, it's as if this whole monitors this virtual machine. I still have the menus if I wanted to, dropping down from here. I still have the power options here. I can pause. That's just like pausing your video or your MP3 player or your audio device. It's the same thing. It suspends it at that point. And when you resume, it resumes or starts up again from that point. And there's a couple of other power options. You can restart the guest, which basically sends a restart signal. It's as if you've gone to your Windows and said restart the computer. And shut down, start up is the same, but there's also this power off and suspend. Power off is not a shutdown. Power off is like you taking the cable out of your computer and just pulling it out. Just taking the power away. It's a hard reset if you like. Okay, if it was a physical machine. Reset is basically restart, but it's a hard reset then restart. And suspend is like pausing it. We've got this power onto firmware. So you know on your real computer you've got a BIOS or firmware. You can go in there to make changes to your physical machine, like the boot order and stuff like that. You can actually do the same on your virtual machine. And if we actually tick this, the next time it turns on, it will go into the firmware directly without pushing any special keys. Let's actually take it out of the full screen mode. We can also go here, which is enter Unity mode, which we'll talk about in a second. And here we can show or hide the console view. So you see how when I've done that, you don't see the actual window. Because if you actually have a virtual machine which is configured to do something like a server, do I need to see the window all the time? No, not really. After I've configured it, after it's actually doing its job and working away, we just want it to work. No one needs to look at it. Okay, so by hiding the console view, we don't need to look at it. But if we want to interact with it, we can bring back the console view and do that. We can also stretch the size. So I obviously can stretch how I wanted to. So that's free stretch. Or if I want to keep aspect ratio, that means if I actually stretch this, it will actually maintain the ratio of the virtual machine. I've obviously made it. I've annoyed my virtual machine bit, so I might just actually restart this. So that restarts sends a restart signal, and it should restart. Okay, let's go back to the PowerPoint while I was doing that, and let's actually give you a bit of information. So we can use full screen mode, like I showed you, where it looks just like the whole screen is dedicated to that virtual machine. In full screen mode, the virtual machine display fills the screen and you cannot see the borders of the workstation. You can also use exclusive mode, like full screen mode. Exclusive mode causes the workstation virtual machine display to fill the screen. You might want to use this exclusive mode if you're running graphic intensive application such as games or full screen in full screen mode. Okay, most times you probably wouldn't need this. There's also Unity mode, which is actually the special display modes. Let's see if our virtual machine's back here. Yeah, there it is. It's restarted. I'll log back in. And let's show you Unity. So hopefully you're a little bit familiar with the fact that I can go inside the virtual machine and launch programs. And that's running inside the virtual machine, okay? No problems at all. But what is Unity mode? So here's the button for Unity mode, or I can actually go to VM and Control Alt U. Sorry, the hotkeys. Let's have a look at that. Control Shift, yeah. Control Shift U. Control Shift U. It's not entering it. Let's look at the preferences here. So with the hotkeys, Control Alt, Unity, Control Shift U. That's what it should, but it's not working. So let's actually go and use this button. When I enter Unity, the window looks kind of funny, doesn't it? It says it's not displaying the screen anymore, because the point of Unity is to actually make the programs that's running in the virtual machine just like any other window that might be running in my real computer. So if I go to my Start button, you should see. Okay, so you can't see because I've got two monitors. But if I actually maybe change it a little bit, so change my display a little bit. I'm going to change my display a little bit. I'm going to make this my main monitor. So make the one that you can see my main monitor. If you go by the Start button, you can see there's another Start button. That's the Windows 10 virtual machine Start button. So I can actually launch programs that's inside my virtual machine. Let's say the PowerShell, and that's inside my virtual machine. If I press Window, this is on my real machine. If I click on my real machine's thing, I can launch the same program, or in this case PowerShell. I'll put them side by side. And you can see that they're both running as different windows, aren't they? But which one's my real one? Which one's my virtual machine? Can you guys tell? Sorry? Which one's this one? That's a virtual machine one. How can you tell? This thing? That's what we call badge. Okay? So that's a badge that signifies it's part of a virtual machine which has been labeled orange. And you should see a bit of a border around it. And if we go into here and we actually go to virtual machine settings, we can actually change that a little bit. So if we go to Unity and it says show badge, show border, we'll use a custom color instead, and we'll use something that's dramatically different. And if we minimize this, you'll see how that's changed colors. So if we had 4 different virtual machines and we put them all into Unity, we could be launching programs out of each of them. And if we give them a different color, we can pick them out. Can you think why we might want this Unity? It sounds good, but why do we need it? Organizing the windows, yes, but why do we even have it in the first place? Why would we want to do that? Yeah, why would we? That's what I'm asking you guys. Yeah, so basically, let me give you a scenario, one example. Let's say we have Windows 10. Let's say we've got a program that only runs on Windows XP. Well, we can't run it on Windows 10. We don't want to run Windows XP. Maybe we can just create a virtual machine for Windows XP and install that program in there so we can still use it. But for our average users, remember I said I think of my mum, okay, as average person. And if you don't know my mum, but my mum is the least IT savvy person I can think of, okay? And what would she do? She would get confused if we were giving her a window of virtual machines. How would I interact with it? Here, it's two windows on the same computer, isn't it? Okay, and I can just tab between them, just like I normally do. If I actually go and launch a notepad, you see that's notepad, and I'll launch a notepad in my real machine. Actually, forget about the notepad in my real machine. I can go to my real machine, go to my PowerPoint, select all of this text, copy, tab to my notepad that's in my virtual machine, paste it in, and do work as if it's just like that. It makes a program that's running in the virtual machine appear as if it's a program that's on your computer, except that it's not running in your computer. When I actually go save to the save, and I'll save it to the C drive, and I'll make a folder here called temp, and we're gonna save this file as test. Inside of temp, it's not saving to my real computer. Okay, if I open up a real browser here and go to the C drive, there's no TMP. This is something else. There's no TMP as I've created. But if I actually go to my Unity start button, start a prompt, you can see it's got that badge, start a Windows Explorer, go to C, there's the TMP, there's that test file. You get me, guys? When I'm running something in this Unity window, it's actually doing the processing and working within the virtual machine, even though it appears as if it's on the real computer. How do I exit out of Unity mode? Well, let's go back to our VMware. Just click exit. And all the windows goes back inside the virtual machine. These are all the ones I've started, okay? So, would we use Unity much in our classes? No. Okay, this is probably the one and only time you'll learn about it, and we pretty much move on and we don't use Unity much at all because we don't use virtual machines in that way. But in a situation where it does make sense, then you use it. For us, we're learning networking. Unity mode doesn't really help us too much in that case. Let's keep on going. So that's so now I've changed my display. It's actually not presenting my PowerPoint correctly anymore. So I'm gonna change my display again, and we'll present it again. All right, that's better. So we can use also multiple monitors. You might see that I've got two monitors actually free with the projector. I'm only displaying one of them to you now. And basically, if you have, most people have multiple monitors these days. I'm sure if I go around the room, who's got more than one monitor? Pretty much everyone, okay? At my desk, I've got actually 3 monitors because it's just so easy to do work with multiple monitors now. So therefore, so if you've got multiple monitors, you can actually make your virtual machine extend across both your monitors. All right, so if we actually have the free stretch on, we can actually stretch it across both virtual machines. And if you can't see my other monitor, oh, that's not smart. All right, sorry guys. All right, so what I was trying to do was show you that my other monitor, you can see half of the virtual machine screen, and on the other half you can see. Okay, so no big deal except that you can do it. And what's even better is that I can actually use this view and auto size. So let me just turn off get it back to free stretch. I'll change it to view. Let me just stretch it again. You notice that my display automatically adjusted to the size of the window. So that's all of those things, Unity and these different display modes, is because of VMware tools. Okay, so we can have weird shaped windows, we could use multiple monitors, and we could potentially have one virtual machine on one monitor, just to make it easy for you to understand that these are two different computers. And we can do loads of things like that. Okay, so we spoke about Unity. So we can do keyboard shortcuts in both the Unity windows as well as our real computers, copy and paste between the computers. What about moving virtual machines? Okay, let's demonstrate a move. So we've got this virtual machine. I'm just gonna, well, you can't move it while it's running, first of all. So I'm just gonna power off it. And I'm going to close VMware Workstation. Okay, so it's just like any file. It's a whole bunch of files. You can't move a file if it's being accessed. So here's my Windows 10 virtual machine. I think this copy didn't really finish last time, so I'm just going to delete that. This is my Windows 10 virtual machine. I can just cut and paste and go to my C drive, create another folder called somewhere else. Okay, and I can paste it here, and it's very quick because it's already on the hard drive. It's just changing where it's pointing to. If I go back to my VMware, if you remember, it's still there, but now it's saying, oh, I can't find the files anymore. Okay, I can't open this virtual machine because the files don't exist where I thought it was. So we can just remove that from the inventory or library. But now we can just open it. So File, Open, and we go to the C drive, is where I've stored it. And I think I stored it somewhere else, didn't I? There it is. And I can just find the VMX file. So when I say VMX file, it actually means the extensions VMX is just the extensions hidden. That's a little bit confusing for me. So I can go to View, and I can say, check this box that says Show File Extension. Now you can see the extensions. Okay, so if I go back here, I'll cancel that and I'll open again. I'll go to my C drive and I'll go in here. You can see that there's a .vmx now. The VMX file is not the virtual hard disk file, it's the configuration file. The configuration file basically defines the virtual machine and pulls together all the resources like the VHD files, the ISOs, and anything else you're using for the virtual machine. So I can just open that, and that defines my virtual machine and what to use. There it is, and I can just power it on now. But when I move it or change the location of it or copy it to a new location, it prompts me. Did you move it or did you copy it? What did we do just then? We moved it. But we could also copy it. Let me just escape this for a second. What we can do is, it's a bunch of files. It's a bunch of files, isn't it? So if it's a bunch of files, I can just copy, Control C, go to my C drive, go back to downloads, and I can paste. It's a bunch of files. It's a large bunch of files. It's 13 gigs, but it's still a bunch of files. So I can make copies of my virtual machine quite easily. In fact, for your other subjects, you'll be asked to go to your drive, download virtual machines to use for a particular worksheet. So if I actually copied it, okay, so if I move the virtual machine, how many virtual machines are there going to be? So if I move this virtual machine from one location to another location, how many virtual machines would I have? Just one. If I made a copy of a virtual machine, how many virtual machines could there be? 2 or more. Okay, and that's very important to making this decision. This is important in making this decision. It's been copied. Remember how I was prompting you, did you copy or did you move it? It's a very important decision, because if you made a copy, let's say we all said, go download this virtual machine from your drive, you're basically making a copy, aren't you? You're putting it on your computer and you're turning it on. Well, the thing about virtual machines, they're great, but when you make a copy of it, they're identical, aren't they? Identical in every way, because they're a whole bunch of files. You make a file of a Word document, it's going to be exactly the same, aren't they? But the problem with a virtual machine or computer is that they have this thing called a MAC address. Okay, MAC address. If you don't know what the MAC address is, it's a physical address that's linked to your network card. Okay, so if I go on my real computer and start a command prompt, and this is one way of actually finding it out. I use a command called ipconfig/all, giving me all the information. If we look at my physical network card, you'll see that there is a physical address. There it is. That's what's called the MAC address, Media Access Controller address. And do you recognize this at all? It's not normal numbers, isn't it? It's hexadecimal. Okay, for those of you who don't know what hexadecimal is, hexadecimal binary are what we use for IT or computers. Decimal is what we use in normal life. Hexadecimal binary means there's two states, 1 or 0. Hexadecimal, hex means 6 really, but the decimal means 10. So hexadecimal means 16 different states. So how does the numbering system work? It goes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But it doesn't stop there. Then A, B, C, D, E, F, which gives you 16 different possibilities. Okay, so in this case, it's B8, CA, 3A, 8, 9, etc., etc. So when we make a copy of a virtual machine, everything is identical, including the MAC address. But can two MAC addresses, identical MAC addresses, should I say, exist on the same network at the same time? No. It's just like can two students exist with the same student ID in the same TAFE? No. So if I actually power this on now, it'll ask me, did I copy it or did I move it? Okay, when you choose I moved it, because there's only going to be one copy, one version of this virtual machine, because you've just moved it to a new location, it leaves the MAC address the same. If you choose I copied it, means there's a possibility of two virtual machines on the same network now. So if I made a copy, then by choosing I made a copy, it's actually going to change the MAC address, so you have different MAC addresses. Okay, so now I can open up the other one that I've made a copy of now. So instead of somewhere else, it's here, and I can open it up, and you can see they're both identical. And that's one way of making a copy. Okay, that's one way of making a copy. Let's keep on going. So you can move virtual machines that was created in Workstation, VMware Workstation, to a different system, to a different location on the same system. And you can also open it with other programs like VMware Player. When you move a virtual machine to a new location, you can move the virtual machine to a host system that has a different operating system. So the best thing is I've created a virtual machine now on Windows. I want to take it home, but I've got Mac OS at home. But I've got VMware Fusion. No, it's okay. I can open that up with VMware Fusion. I've got Linux at home. I've got VMware Workstation for Linux. I can still open this virtual machine up. You see how it works on all these different situations? And it also has this ACE, this thing called ACE, Assured Computer Environment, which means just because you put on a different piece of hardware, different computer, it's not going to have. You're now late, Pierre. Thanks. It's not going to have. It's still going to work, that assured computing environment. Okay, so it means you can move from system to system without any possibility they won't work properly. Okay, there's some exceptions, but generally that's fine. So limitations of moving. So you can't move your virtual machine, which is created on a 64-bit system. So we spoke about that the other day. So if a 64-bit system in front of us, we've created this virtual machine which is 64-bit. We can't then move it to a 32-bit system and expect it to run. That's the limitation. But you can move a 32-bit virtual machine from a 32-bit host to a 64-bit host. That'll work, but you can't move backwards. We're going to talk about cloning in a minute, but there's also moving a linked clone. If we move a linked clone and it loses the parent, yeah, sure, it's going to panic and it's not going to be able to run properly. We'll talk about that in a second. when we copy a virtual machine, we can copy it to a new location, to a new system. It's new location on the same system. When you copy a virtual machine, we spoke about the MAC address. If you have more than one copy, there's a potential of having two virtual machines with the same MAC address on the same network. So therefore, when you choose I copied it, it will generate a new MAC address. We can also look at the configuration file and hack it if we want, if we're smart enough. If I go here, remember that VMX file that I said was a configuration file? It's an ASCII file. I can just open it and edit it with a text editor. There it is. There's a whole heap of things that define how the virtual machine is, what files to use, what things to use. Some of these are easy to understand. Like for example, the file name of the virtual hard disk. See the SCSI file name is this one. That's the actual virtual hard disk file. If I actually go back here, there it is. That's the virtual hard disk file. It's linked to this virtual machine. Other things like, let's have a look at that MAC address, if we can find it. There it is. There's the MAC address of that computer. Just remember the last 4 digits, 30F4. Let's go into this virtual machine. Which one I was looking? Which one? I'm lost now. Which one was I looking at? I was looking at the original Windows 10, which is this one. Okay. So it's a bit confusing once you have two exactly the same and you're switching between the two. But you just have to be conscious that there are two and you've got to work out which one you're looking at. Remind me later. So if I open up a command prompt inside this virtual machine now, do the same command as before. There's the physical address. Remember the last 4 digits I told you to remember, 30F4. 30F4. Okay, so let's actually turn this one off. Power off again. I know it sounds a bit annoying. Power on, power off. What is he trying to do? If we did have a conflict, we want to change it. 1 or 2 ways to change it. Here, I can just change it to F6, for example. Okay. Really, the MAC address doesn't matter as long as it's hexadecimal. Okay. I've got to make sure I save it. And when I actually power this on again, it will read that configuration file, load up the things that's required from the configuration file, like what are the virtual hard disks, what is the MAC address, and many other things. And once it's actually started up, we can go check the MAC address again. Hopefully it's changed. So the only thing I've changed was from F4 to F6, okay? Let's have a look. So let's log in again. And so is everyone following me, by the way? Obviously, if I'm going too fast, I'm saying something you don't understand, pull me up, ask questions. Otherwise, I'm thinking everyone's good and I'm just going ahead and keep on talking. So if I do my IP config again, it hasn't changed. Let's go have a look at the file itself. Did it change it back? Oh, that's the VMX file, wasn't it? So it's wrong one. Let's have a look. Where's the V? Here it is. Edit. No, it's changed the back for me. So it's rewritten what I've written. So I need to change that. I can change that manually as well, but I can also go to the settings and I can actually go to the network card. I can go to advanced. Here's the network MAC address. Okay. And let's say I had a problem. I can again shut it down. I should have just powered off. Shutting down takes longer. But the hard reset is faster. That's why sometimes we hard reset computers if it's not responding. Okay, so let's go back to settings. Going back to that network card, advanced. Now you can see I can actually change it now. Type it in or click generate. And when I click generate, it just generates a random new one. Okay, and hopefully Hopefully it's not going to conflict with any other ones. So I'm going to turn it back on while we go back to the PowerPoint. Okay, what about cloning virtual machines? That's a good point. Cloning virtual machines, as the name suggests, makes a copy, makes another virtual machine based on a previous one. Remember how we manually did that by just copying the files? But that's just copying the files. What we can do is actually we can clone it. So we can go to VM, snapshot manager, then click clone. We can clone the current state right now, as it is right now, or we can clone a snapshot. So when we clone a snapshot, it's cloning that point in time. When we're cloning, where are you now? We're cloning as it is right now. But the thing is, when we create a clone of as it is right now, it's going to create a snapshot of that point in time anyway. Right. Okay, our computer is actually on. Let's just power off. All right, let's do the clone now. Another way to do the cloning is right-click, snapshot manager, gets to do the same thing. So let's clone where we are right now. So I'm going to click clone, and it gives us a couple of options. Obviously the current state or a particular snapshot. So we've decided that we're going to clone the current state, how it is right now. So now we have two choices, a link clone or full clone. Let's talk through some of the advantages, okay? A link clone is really quick. It will happen less than 5 seconds when we do it. And it's very small. But it's dependent on the parent because it's actually going to go back and use the original virtual machine's files in order for it to work properly. No parent, no link clone.
So you can't move the clone to
Oh, you can move to the clone, but you have to tell it where the parent is still.
No, but you can't move the clone to a different machine.
Oh, yeah, you always have to be able to access the parent files. Yeah, that's if that's what you meant.
You can move it wherever you want, but not on parent file. Yeah, that's what I was about to say.
Yeah. So whereas a full clone is like an independent virtual machine. It's a full copy. It takes a lot longer. It's a lot bigger, but it doesn't need a parent. So the way I put it is that this is like a toddler, and the parent, it's a toddler. So you've probably seen in the shopping centers, if a toddler lost its mum and dad, it's going to panic and go, "Oh, where's my mummy? Where's my daddy? I can't live now." So it doesn't function. Whereas this full clone is more like a teenager. I don't need my mum. I can go off by myself and do what I like. Okay, I don't need my parent virtual machine. So let's make a link clone first because it's fast. I'm going to call it linked clone just so it's easy to identify. Where am I going to put it? I'll put it in my, I can type it in if I wanted to. I'll put it in my C downloads folder, or I can browse for it. Okay, finished, done. Remember how I said it would be very quick? It's done. Here's my link clone. Power up. It's done. It's running. No problems at all. All right. So it was based on this virtual machine, if you remember. Okay. So let's actually do the same thing now. So if you notice that it created this snapshot of the link clone here. Okay. So we are this virtual machine is here. We'll clone again, but this time we'll create a full clone. We'll call it full clone, and we'll save it as. This is going to take way longer. See downloads. It's almost like copying the files anyway. Full clone, and then it's going to take a while. Okay, because it's making all that copy. You notice that in the cloning, we didn't have to choose I copied or I moved it because it actually knows as a clone. So it knows as a copy. So it's automatically generated a different MAC address. All right, so cloning virtual machine is a powerful tool. And we'll use it many times in our classes, especially when we get further into networking, because if we created a server, we need another server. Do we create it from scratch? Or do we just go clone, new server? Okay. Full clones is a standalone copy of an entire virtual machine. You can treat it like any other virtual machine, no problems there. Whereas a link clone requires the parent or the original virtual machine to function. But the benefit of a link clone is it's very small, very compact, and it actually is so quick to create. So you can see that I'm still creating this full clone, whereas that link clone was done in a flash almost. If you have limited space on your solid state hard drive or your personal storage, link clones is the way to go. So in our classes, we always will use link clones because it saves your solid state hard drive. In a real live production network, if this was enterprise virtualization, there will be no such thing as link clones, because in the enterprise virtualization, the virtual machines can be moved from host to host, and having that dependence of another virtual machine just breaks things. All right, okay, let's see how's it going. Okay, it's done. So first of all, let's actually turn on the full clone as well. You can see the link clone's working and the full clone is about to work as well. Let's investigate the size. Okay, let's actually, while we're investigating the size, full clone's turning on, we'll just power off so we know that they don't have any temporary files. Because when you have temporary files, it actually contributes to the size of the virtual machine. So if you remember, we made a full clone and a link clone here. So full clone, 9 gigs, or 10 gigs almost. Link clone, 82 megs. Okay, and that's because we haven't made any changes to this link clone. So obviously, it's based on the original parent machine. So if you remember, that was here. And so therefore, even though it's stored here, when it's actually running, it's actually reading files from the parent. Any changes we make is actually going to be stored here as a difference between the parent. But anything that was already there previously is going to come from the parent. So you saw that they were both running okay before, then I turned them off, right? Let's break it. Let's see what happens when we actually go to somewhere else. Here's the Windows 10 that was the original virtual machine, guys, if you remember. Oops, I've deleted it. Accidentally, of course. Now let's go and see what happens to the full clone. What do we expect? For it to what? Bit up, yeah, bit up as normal. Let's see. Yeah, looks like it's going through it. It's doing the automatic repair because I stopped it from booting from last time. Okay, but it's gonna bit up. Let's look at the link clone. What do you expect? What do we expect to happen here? It's gonna be broken, isn't it? That's what I expect. Let's see. It says, "Oh, mummy, I've lost my mummy. Oh, daddy, I can't function. Please help me find my parent." And at this stage, you could say, "Oh, don't be scared, little boy or girl. Your parent is here," except that I deleted it, didn't I? So no good. But I know I made a copy of it. So how about this other parent? That's exactly the same, and now it works. Okay. So obviously with a link clone, just be careful. Oh, look at that, because the process is locked a portion of the file. Okay, because that was not the original parent. Okay, because it actually created a snapshot. So it's not going to work. So we'll get this full clone and we'll get this restarted. So my bad, I deleted it. But that's hopefully illustrated a point. Illustrated that the link clone needs a parent. No parent, no link clone. All right, so this full clone is turning on. And if we go back to this original virtual machine, it's because I've deleted it. It's actually, yeah, can't find the files either, so I'll just remove it. So this is a Windows 10, which is a copy, but it's not the parent of this link clone. The next thing we're going to talk about is encrypting. So have we heard of the term encryption before? What does it mean? To lock it? To lock it away somehow? How do we lock it away? So if I encrypt something, I'm obviously making it locked away from other people, right? How does it do this? With a password? Yeah, usually there's a key to unlock it, definitely. But what does it do to make it protected? What does it do to the file or the contents of the file to make it, sorry? How does it hide it? Okay, how does it hide it? That's the question. It's in a container. I'm not sure if that's the case. Okay. All right. Let's see if this will extend this far. All right. So let's let's do it on the computer because I want to put it in the video as well. Okay. Let's put a notepad. Get a notepad instead of a whiteboard. So here's a notepad. I'm going to type my name. Can you read that? You can all read that, can't you? Can you read the next line? What is it? Yeah, is that, if I told you that was the same as Alex, and I didn't tell you that, could you read it? Not with the key, without the key, right? So basically, what I'm trying to illustrate here is this is what's called a substitution cipher. Okay, you might have heard that term. Okay, it's like coding something that you can read from plain text to something that is unreadable because it's called ciphertext. Okay, so it's just like World War II when the Germans had their machine to encode all their transmissions and stuff like that. They just turned something that's readable or understandable into something that's garbled. Okay, they both mean Alex. But one's either readable, one's not. But what did I do? What did I do? I didn't just randomly put letters there, did I? It's a systematic approach, isn't there? So what did I do? I substituted each letter with the next letter, didn't I? That's just a simple demonstration that there was a method to my madness. That method is called the algorithm. Okay? So I've substituted the next letter for the I substituted each letter with the next letter. Simple. And obviously, now knowing this, you probably can decode all my encryption now. Pretty easy example, right? But so the key was 1, if you like to think of it. If you imagine the alphabet in a cogwheel going in circles, I've just turned that cog one step next to the next letter, didn't I? But if it's a wheel, I can just keep on turning. I can turn it 300 revolutions, couldn't I? Or 301 spots to substitute it. But the key thing is the method is the same. It's just the thing that makes it different every time is the how many clicks do I click it through, right? So that's what we call the key. Okay, I know this is a simple example, but just hopefully it illustrates it. It's a simple example, and we are just changing the notches that we're moving the cog, and that changes the result, doesn't it? Okay, if we change it to 28, click 28 times, it will get a different result than if we change it to 17. So if we know the key is 17, then we always get the same result back, decryption. So basically, what are we talking about with encrypting a virtual machine? Well, what if we had a virtual machine that we didn't want other people to use? What if we had a virtual machine which contains data that we don't want anyone to see? So what you have to do is you can't encrypt a link clone or parent of a link clone because obviously they share data, they share information. What you can do is you can actually, I suspended it. I'll power off it, which will discard the state. What I can do is I can actually encrypt a full clone or a full virtual machine. So I go to the access control. Right now it's not encrypted. I can just click encrypt and I'll give it a password. So if you do go and encrypt it later, make sure you use a password you can remember. Our common password for the classroom is password1 with a capital P. So if I choose encrypt now, it is going to be slowly going through every bit of information, every bit as in 1 or 0. And it's going to scramble up using an algorithm. And that password 1 is our key. So you might have heard this, like it's a 128-bit encryption or 256-bit encryption. It's basically that's how long the key it generates is. It's obviously something that's longer, is harder to guess than something that's shorter. So therefore, the longer the encryption or the bigger the encryption, the more safe it is generally. All right, so it's going to do that. Okay, let me just finish off by let it do that while I'm talking about it. So it's very important you keep a record of the password. Encryption applies to all snapshots of the virtual machine. If you change the password for an encrypted VM, the new password applies to all snapshots. Some restrictions: you must power off the virtual machine before you can encrypt it. It's supported only on VMware Workstation 5 or later, not before that. Not that we need to worry about that. We're up to 15. If more than one unencrypted virtual machine shares the same virtual hard disk, that virtual hard disk cannot be encrypted. What does that mean? It means, you know how those VMDK files? Yeah, let's go here. Let's go back to my full clone. So you know how these are VMDK files? They're virtual hard disk files. They're the big ones. But the thing is, I could share this virtual disk file with another virtual machine. I could just mount this this virtual disk into another machine. And if I have, I can't encrypt it on one of them because the other one can't read it, can it? Okay. Okay, let's see if, yeah, some other encryption restrictions. You cannot encrypt a linked clone. If you encryption for the encrypted virtual machine or the parent, you cannot encrypt a shared or remote virtual machine. You cannot upload a encrypted virtual machine to a remote server. So we can actually remotely control virtual machines on other computers. Okay. So when we go here, this is not something we're going to use, but it's more similar to the enterprise virtual machines. If we have a shared virtual machine, for example, this, we were working on that full clone, right? So let's actually power this off. Yeah, we can actually upload this to a vSphere server and run this somewhere else. Okay, so let's get back to, and we can actually create a shared virtual machine if we wanted to, and then that can be used by other people on the network. So let's look at our full clone. It's actually encrypted. For you, it looks no different right at this stage. And that's because we're already in it. Let's actually close off VMware Workstation and relaunch it. Here it is. See that full clone? It's got a little lock thing on there, hasn't it? Here's the password. We need to enter the password. If we don't enter the password, there's not much we can do. We can't open it, we can't turn it on. But you're probably going to ask me, can you delete it? Hopefully you ask me that. And the answer is yes, I can still go delete it. But that's not what encryption is protecting you against. It's not protecting you against people deleting it. It's just protecting you from people trying to accessing it and reading it. You get me, guys? Deleting it, no problem. No one can read it then. My data's safe, my secret's safe. But deleting it is not a problem. But unless you have the password, once you enter the password, it becomes just a normal virtual machine. If I want to take off encryption, I will go back to the settings of it, options, access control, and I can change the password or remove the encryption.
So you have a
Yep.
host
Yep.
and a link. If you encrypt the host, can the
You can't encrypt a host if it's got a link clone. Yeah. You can't encrypt the parent, sorry, if you've got a link clone. You have to remove the link clone first of all. All right. Yeah, so right now, I know I've spent a little bit more time than I wanted to on here, but I just want to make sure we're thorough. So what I want you guys to do now is work through your second worksheet right here, which is we'll go through and do some of these things we've demonstrated today. All right, so